Gradient definition. It is very important to have a good and solid definition of the word gradient. In mathematics, gradient is a very, very important word, and it has a lot of applications in all other disciplines. So let's first begin by how to calculate gradient. That very popular formula, y2 minus y1 over x2 minus x1. Some of us normally call it rise over run. Okay, so we can put some words to those symbols. Rise over run. Very popular way of abbreviating it. Rise over run, which can also be interpreted as vertical change So vertical change here meaning the y-axis. Okay. Going back to geometry, the y-axis, the Cartesian plane, the y-axis, and you have horizontal change. Which is the x-axis. Horizontal change occurs on the x-axis. All right. Right, so we're going to apply this formula for gradient using this example. Find the gradient of the line that joins these 2 points, 8, -3 and 6, -11. So in our solution, we first have to label those 2 points. What is 8 and what is -3? Let's begin. So we can go to our insert equations. And beneath it, we want to write some labeling. So since 8, we can reading from left to right, we can consider 8 as the first point, as point number 1. So I can put there point number 1. Point number 1 and 6, -11 as point number 2. Okay. So 8 now would be x1, the first x, reading from right to left. And -3 will be y1, to appropriately label the coordinates so that we can substitute into the formula we have just discussed with regards to gradient. So we can call -3 y1. So you have x1 and y1. And take a look at the formula. You have x1 and y1 right here. So we have just identified x1 and y1. What are we missing to identify x2 and y2? So we have 6 and -11. And we all see where we are going with this. That 6 will be x2 and -11 will be y2. Okay, put some distance here. Right. So now, let's copy down this formula. All right, go with insert equations. All right, M is equal to, and the fraction, numerator and denominator. So y2 minus y1. y2 is negative 11. Subtract y2 subtract y1. y2 subtract y1. y1 is negative 3. So you have negative 11 subtract a negative 3. Okay? y2 minus y1. Then in the denominator, we have x2 subtract x1. x2 is 6. And then subtract x1, which is 8. Okay? So we've got to do our calculations. Negative 11 subtract a negative 3. So we can say negative 11 plus 3, because there are two negative signs multiplying to each other. A negative times a negative is a positive. So we have negative 11. Okay, negative 11 plus 3. And 6 minus 8, that will give us negative 2. All right, equal negative 11 plus 8. We have negative 11 plus 3, sorry, negative 11 plus 3. That will give us negative 8. Divided by negative 2. All right. And we know a negative divided by a negative is a positive. So the negative cancels out here, negative. So you have 8 divided by 2. And I just want to do another important step just to stress the importance of the definition of gradient here, which is implicit in the formula. So I'm going to simplify this fraction. I'm not just going to say 8 divided by 2 is 4. We know that already, but this very important step can help us to appreciate the definition of gradient, because that's what this presentation is about. So let's simplify that fraction. 8 divided by 2, 2 divided by 2. All right. So what we get now is 4 over 1. All right, 4 over 1. So our gradient, we calculate our gradient to be 4 over 1. So when we come here, right, m is equal to 4 over 1. Okay, m is equal to 4 over 1. Now let's go back to the definition of gradient, which we established here, especially this one, the one in words. Let's copy this. And let's put it side by side by our definition right here. So as you can see, the vertical change, which is on the y-axis, is 4, and the horizontal change, which is on the x-axis, is 1. So this is why now one of the definitions, because there are many versions of the definitions for gradient, extracted from this formula. So we can write hence gradient can be defined as the rate, because a rate implies the measure between two entities. We can even check it out. Rate definition. And here it is, the definition for rate. According to Google, it's a measure, a quantity or frequency. That's a number. A quantity is a number. Typically, that was measured against another quantity, one against the other. So you have an interplay of two variables, two numbers, and that will provide the rate. Okay, that number, one measured against the other. Okay, so this is why here we can see gradient can be defined as the rate, one variable measured against the other. We're talking about y and x here. All right, the rate at which the y variable or the y values, let's just use values here, vary, all right, with respect to exactly 1, and that's where that 1 come out. You see 4 over 1, okay, with exactly 1 increase, because that 1 down there will always be positive. So the gradient, the rate, which is 4 here, that's the vertical change, can be positive or negative, okay? And it can be any number. It can be a decimal, but the horizontal, according to the definition, the x, origin of the x values must be an increase of exactly 1. And then we can talk about the rate. So hence, gradient can be defined as the rate at which the y values vary with respect to exactly 1 increase of the x value. Speaking in terms of the Cartesian plane, x and y axis. So therefore, m equals 4. Let's use the equations. M equals 4 implies that when the x values increase by exactly 1, okay, the y values increase, because 4 is positive, by 4, that rate. Okay, very important word, gradient. All right, so here we started. Please don't leave college algebra 1 without a definition of gradient. Okay, and here's the formula: rise over run, vertical change over horizontal change, y2 minus y1 over x2 minus x1. Then we applied it now to those 2 points. We labeled the 2 points, x1, y1, x2, y2, reading from left to right. Substitute it to the formula, do our calculations, and we get 4 over 1. 4 vertical change, 1 horizontal change. Increase actually, okay? So therefore, you can even specify there, it will always be an increase. Okay? Horizontal increase. Okay, of exactly 1 here in that case, as always. So hence, gradient can be defined as the rate at which y values vary with respect to exactly 1 increase of the x values. That's one way to phrase the definition of gradient. Okay, you can rephrase it in another way, but it has to imply the same meaning. So therefore, m is equal to 4 implies that when the x values increase by exactly 1, the y values increase by exactly 4. Please don't leave College Algebra 1 without a firm definition of gradient.